Okay. All right. So the recording is on. You all may not realize, but we've done quite a bit so far. We've done arrays, we've done operators. We actually inadvertently did binary last class. We did sequence selection. Yeah, we know the properties of algorithms. We understand the basics of input output in C. We could express up to decision logic and looping in C. We have done quite a bit for essentially what is 1 month of work. I have to applaud you all that we've gotten through really and truly quite a bit of work. Um, we still have some to do, but I think that for the most part, most of us are at a reasonably comfortable place. We're at a reasonably comfortable place. I want to ask right now if anybody is not in a comfortable place. Does anybody feel this might be a bit much. These are your times to say, don't study that the recording is on a little bit, but it's these are the times to say where you could say at any point, you can message me at any point. Right? I also am very aware that there is a lot that is going on in your own lives that sometimes this is not your only subject, even though I have to treat it like it is your only subject. You all have, things to go on. The pandemic is treating everybody very differently. There are a lot of things to be concerned about in terms of factors that can keep you from doing the kind of work that you want to do. But at the same time, we have a goal, and I am here to facilitate you towards getting to your goal. And that means that at any point, preferably not the week of Christmas, but the week before and the week after, if you are going through some stuff and you want extra assistance, you can message me and I will try to assist you as best as possible. Okay? Um, and I don't think I want to give you all like any over the vacation. Um, I don't want to give you all any over the vacation assignment, but I want to ask you that over the vacation you spend some time thinking and reflecting on any topic that you feel might be a challenge, and you watch over the classes associated with those topics. Okay? Because I need for us when we come in January, we have to hit the ground running. All right, because from January we have to finish up everything with programming. We have to be able to develop the balance of or the major part of our SB by the end of February, and within the month of March we have to just tweak that SB accordingly. And we still, while we tweaking from the end of February to the end of March, that's when we will be also be taking a look at some unit module 1 topics. Right? Those topics aren't hard. They're a little theory based, but they're a little mathematical in places. Okay, and it's not just like simple theory. Because this is computer science, there is there's a level of understanding that needs to take place with regard to those topics. So my thing is just communicate, and we can work together. No problem. All right, good. So seeing that we have that understanding, and seeing that I now know that everybody, and my only point of reference when we online is to see Clement shaking his head or shaking his head. So, so if it is that I see, and Clement has been, yes. So I feel like if Clement represents everybody, because this is the one person that I have on visuals. Everybody else, other face could be like, you could be weeping right now. Clement, don't start to weep. What you doing? Clement, I already know that Clement is there with it. So I have to read. And I mean, yes, we will have physical classes. I don't know how school will be structured um come January, right? That's up for administrators and the government and stuff to say. But I mean, I will still try to get in the physical sessions because I do know that that has been helping. It's been useful, but this is where we are now. This is what we gotta work with. So with that being said, I want to share my screen. And we're gonna just take down little notes on some notes on well, just talk through the concepts of arrays in C, and we will we will we'll take a look at it in programming. So what is an array? Right? So arrays. What is an array? An array is a reasonably simple concept. An array is a variable. So it's a variable, right? This should be like a capital A, right? A variable that allows a programmer to store multiple values of the same data type. So we have a structure of, something that allows me to store multiple values of the same data type. And with a normal variable, we have something called a name value pair. A name value pair. Whereas if I say int x is equal to 90 as a statement, the name of this variable is x and the value of this variable is 90. This is my name value pairing. What an array does is an array allows me to define the size of the variable, the array variable that I want. So an array variable has more than a name value pair. It has a name value index pairing, right? So what we do is that we start off by saying int x is, sorry, not x, let me name it array, and we say the size of the variable that we want. So if I want a value that can hold 10 different, a variable that can hold 10 different values, this is what I do. I have my data type like any normal variable declaration. I have the name of my array variable, and I declare the size of my array variable. This is an array declaration. And what happens after that is if I'm to visualize what this will create, is that this will create a variable called array. So this is the name. And we have space for 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 different values to be stored potentially inside of this one variable. These, so let me annotate, this is the name. This here is called an element, right? And this is where the value is held. So this holds the value that will be stored inside of the array. And to get to a particular element, I have to access that element via what is called a subscript or an index. So I have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So notice that we begin at position 0 here, not at position 1. Sometimes when we're doing, if it is that we're doing arrays in pseudocode, it's very likely that you'll see the array value starting at 1. But if it is that the array is declared in C, the first element in C, the first subscript or the first index, right? So this is your array subscript / index. And what this does is that it allows me to specify a particular array location. All right. Any questions so far?
So you can repeat
Yes.
what you announced with
Yes, sir.
Okay. Yeah, I will repeat. I was just saying that the array variable has 3 parts. The array name, which is what we will access like any other variable. We'll access values via the name. We have the element, which holds a particular value. And then we have the array subscript or index, which is used to specify which particular element we wish to access. Okay? So if it is that I wanted to store a value in the first position, so to store a value, to store a value in the first position of the array, what do I do? I will say array at position 0 is equal to whatever value that I want to store. So this will allow me to store a value in the first position of the array. And I could do this using, scanf or whatever to store my value as well. I don't have to put a value inside of there, right? So I'll put here or scanf %d ampersand array at position 0. So you treat it just like a normal variable. You treat it just like a normal variable, and we want to put values in this first position of the array. Okay? So to access, of course, to access a particular location, what do I want to do? I also have to say what location I want. So example, to print out the value of location of element 5 or location 5 in the array, right? I could say printf, this is assuming that I would have put something in there at some point, %d, and I'd say array at position 5. And of course, array at position 5 is the 6th location in the array because array locations start at position 0. We could see that. Let's just go back. And we see that location 5 is the 1, 2, 3, 4, 5, 6th position in the array. Okay? So if we wanted to pull a location, we want to print out that value from that particular location. We use the index to say where that location is. If it is that I want to populate an array, so if I want to populate an array, okay, if I want to populate an array, and I tell you before the end of today, we're going to have a lot of fun because I'm hoping to teach some random number generation in C as well today for an exercise. Okay, I see Clement shake his head, so I assume that everybody is going to be having fun. All right, other people have to start turning on the camera. You know, so somebody when they see Clement with his computer in school, they'll break the camera on it or something. So like Clement just setting us up. All right. So to populate an array, we can use a for loop to access every element in the array. So let's assume that we have an integer array that has 20 positions. If I have an integer array that has 20 positions, and I want to populate all positions in an array with input from the user, and anytime you see me writing like this, just assume that I've done whatever else in the code, right? That this is just a snippet of code. And we put in the code in its, when we have to do the program, we'll put the code in its appropriate place. Everybody's fine with that, right? We can agree on that.
Yes, sir.
Right, so we create this array with 20 elements, and then we want to say int I, which is a counter, and we could say for I is equal to 0, I is less than 20, I plus plus. What do I do? I want to say scanf %sign D ampersand array at position I. This will cycle through all possible locations in the array and prompt the user to store every value in a different array location, starting at 0 and ending at position 19. So we have I.
After the comma, after the %D, what is
ampersand? Sorry.
Okay.
The and sign.
So you can just go over why let's put the plus plus on the I.
I plus plus is shorthand for I is equal to I plus 1. So this is the increment, right? This is the increment statement. And what this is saying is that once you hit down here on the for loop, carry the value of the counter up by 1 and check to see if this condition is still true. You with me?
Yes, sir. And the semicolons in the bracket, that's saying and.
The semicolon in the bracket separates. So essentially, the for loop is made up of 3 statements. The first statement is a start value. The second one is a continue condition. And the last one is your increment. So your increment pushes that start value towards the continue condition. And as long as the continue condition holds true, then we will go up to that, whatever the continue condition states.
Yes, sir.
Okay. So I think we learned enough about arrays at this point to jump to our compiler and actually start coding some arrays, right? Because we could talk about it as long as possible, but sometimes it's always just best to see it in action in code. You all do agree?
Yeah, I agree.
Alright, good. So we can move forward. Anybody else want any explanation before we move forward, or no?
So to get it straight, right? An array is just like a normal variable, but you could store more than one element in it
Yes, of the same data type.
at the same data type.
Yes. Okay, and we will actually in C exploit that property to create strings. All right.
So,
I know that yeah.
Yeah, so basically, instead of going through all that torture data they say, we could have basically use arrays and store it in and then print it backward.
No, I think the torture was with it. What do you mean the torture for with the numbers, with the binary numbers and stuff like that?
Yes, sir.
No, yeah, but you see, I had to do that before I got to here because I need you guys to think algorithmically. Okay, so I mean, there are going to be some instances where you might be able to use arrays to achieve the same thing, but now you have two techniques under your belt rather than one. Okay, so it's like, oh well, this array not working. Maybe I can use that other thing. All right. So yeah, go ahead.
No, sir, I just saying yes, sir. It was with it.
Yeah. You can't dispute that with me. All right, you can't dispute that with me. All right. So right. So we want to move towards the code. So I'm gonna just stop sharing the screen for a second so that I can start up things associated with the compiler. Okay. So and let's start back. All right. So you all see my screen once again, yes?
Yes, sir.
All right. Hey, and before we start, this game, this Wild True Learn game is free on Epic Store right now. It's like an intro to programming game, but it takes it more from like a data science approach. But a lot of the concepts that we meet are also going to be covered in the game, right? I think like they have some little modules that represent decision boxes, modules that represent repetition, stuff like that. So check out the game. Check out the game. It's free this week. Normally it's like $5 US or something. So for it, I mean, at the end of the day, it's a way to play a game and learn a little bit of programming. It could only help right now. Okay, so I recommend it as something for you to do that. I see as pretty much fun for in terms of learning, because especially like if you like puzzles. I mean, generally it's just like a puzzle game, but it's applicable to us because it is also from the perspectives of puzzles and programming. Okay, so we want to start our file. This upper six stuff. File C22. Right, lower six stuff. This is arrays.c. So we want to start with arrays, and I have no problem with you going along, but just make sure that you could follow along while if it is that you typing while I'm going through it, right? Include stdlib.h, and I've updated the folder on Teams under files for our class. I've updated it with everything that we've created so far in class. So you have access to all the class files here. in teams. Okay? So just make use of that if it is that you're going over your notes and stuff like that. Int main. All right. You know, these afternoon classes is be harder to teach for programming than morning classes. Morning, your brain fresh and all of that. Afternoon, I just finish eating. It's hard. So sometimes if you see that I make a mistake, like a obvious mistake that not supposed to be, like mistype something and just continue, feel free to call it out or feel free to ask a question about it, right? Either way, when we press compile, you'll get an error, we'll get some sort of thing, and I'll address it then. But if it is that you see it, just say, hey, sir, why did you put that there? I'm fine with that. All right. It mean, okay, so we want to do an array, just a basic array. And I'll do two things with you guys. I will do arrays and I will do random number generation. And so the first thing that we want to do is that we want to be able to create an array and just simply populate the array and print out the array. So that's what we're looking to do in this first C program, right? Create a C program that allows a user to populate an array with values, and then to populate an array with values, and then store those, and storing those values in the array, in an array, and then print all values from the array out to the screen. Let's see if we can do this. All right. We have int main, and we have to have an array. And we have int, we can name our array R. Let's just have 10 values in the array because we don't want to be stuck entering values. And we also have I for a counter that we saw in our example when we were in the whiteboard. And what we'll do is that we can say just simply printf, not printf, but for I is equal to 0 semicolon, because we're starting at 0, because 0 is the first index location inside of an array. Okay. We say I is less than 10 semicolon I plus plus. And what do we want to do? We want to print out to the user printf enter value, all right, an integer value, let's see. And then we want to go on to scanf, and scanf %d ampersand, and we have to see array, the name, we have to see the location where we want it stored. Okay, semicolon. Hold a second, please. All right. Yes, sorry about that. So this here will allow us to store. So we basically saying for every location in the array, ask the user for a number, and then we want to enter the number and store it in a free spot in the array. And of course, we still have to put our get jars. You don't want to have a set of garbage piling up in the input buffer. And then after, it's the same thing basically. To print out, we have to traverse the array from start to finish and say print out each location. There is no way in C to just simply say print an array variable. Print all the contents of an array variable. Just C doesn't allow that. Okay, that's just the way that the language is. All right, you could easily write a function that will take up the contents of a numerical array and print it out if you want like a way to do it, but we haven't learned to use functions yet. So for now, if we have to print out content from an array, this is what we have to do. We can use back the same I is equal I is equal to 0. I is less than 10, I plus plus, and we just simply put the printf statement here. So it's not a glamorous program, but it's functional. And we put a getcha at the end here. Hold us. Are we good, right? Mm-hmm. Right. And this would be it. So let's give it a compile, no errors, run it. We have 10 values to enter. So we want to enter 5, 8, 2, 9, 10, 80, 8, 12, 99, 2, 3, 9, and it prints out the values that we have. I'm sure Real would be pleased because I know that Real for the longest while has been wanting a way to keep all the values entered in a list format. Okay, so Real, does this speak to you in terms of making life easier?
Sir, I don't think it was me, sir.
It wasn't you, or was it Hanson? Somebody was behind
Yes, sir.
me.
It was me, sir. It was me.
It was Hanson. Sorry about it then, Hanson. Right? Hanson was not happy with the fact that his variables were being lost, essentially. So Hanson wants to hold on. So Hanson, you're already envisioning this as some life changer in terms of programming.
Yes, sir. If I had noticed before the pseudocode assignment had was due, sir, would I be over for the assignment, sir? Would I be
No, listen. The pseudocode assignment we had to do it as they asked. And even the programs that I put up for you guys to do for next week, even those programs, I wanted to put it in such a way that you could use or you could not use an array. I wanted to give a specific questionnaire, and I know that it would involve an array, but I know that it would also involve tiers. I'm asking, now that you guys know arrays, can I modify it to get that?
No, sir.
No.
See, like a challenge.
sir. Hey, whoa, I don't know about that one, buddy. Sir, give me a little Christmas miracle, sir. We'll put it in.
I can give you a Christmas present and send an assignment for you that will, allow you to manipulate your arrays in the way that you want.
Nah, sir. I think we're good, sir. I think we're good.
Good. I see Clement shaking his head. Clement is the only person whose visuals that I have. So, I feel like in the back of my mind, the only thing I might remember is Clement shaking his head and be like, yes, these students wanted this. So, well, we'll see how it goes. I'm not modifying the assignment. I might just give you all an extra practice assignment or something so. But that one will not be for marks. That would be for your own betterment. Okay? All right. Nobody said okay there.
All right, so you send it as a private kind of message.
No, everybody will get it. Everybody will get it. It's just that, it's not going to be mandatory. All right. So we want to see what we can do with arrays here. We want to see what we can do with arrays here, and maybe I could teach, as I say, two birds with one stone. I want to teach the concept of random numbers too. Okay, so I'm going to go back to the drawing board, and we're going to talk about random numbers as a pseudocode concept. So we have like random numbers. And random numbers are kind of actually important to computing. Okay. While what C have is not like truly random, it's not like the most random of numbers. It's random enough for most purposes. And what we could do is, I'm just going to show, say for instance, like if I had to write a pseudocode algorithm that said, okay, write a program that prints out 10 random numbers. Because pseudocode is the way that it is, pseudocode is meant to be very easy. So if I had like a random number generator in pseudocode, I would say, and I had like a program that said, make a random number or print 10 random numbers. Let me see. Between 1 and 100. Okay, we might use a function called rand in pseudocode, and rand returns a random number between 0 and 0.99999 inclusive. And what does that mean? It means that you can get any random number between 0 and 0.99999, or you could get 0, or you could get 0.99999. All right? So how can we utilize this? Let's say we wanted to get a random number between 1 and 100. Okay? Let's say we wanted to get a random number between 1 and 100. How do I change this now to get a value that is between 0 and 0.99999? Well, what I can do is I could say, and we want to print 10. If I wanted to write this as pseudocode, I could say for x is equal to 1 to 10, right? For x is equal to 1 to 10, step 1, num is equal to, for x is equal to 1 to 10, step 1, num is equal to rand. And what will store inside a rand is some number between 0 and 0.99999 or whatever. And then if I then say, all right, if I say like integer, right? Or if I say print integer num by 100, what should I get? Because this is a some random floating point number between 0 and 0.99999, I will get either 0, any number from 0 to 99. But my range is asking me to print it between 1 and 100. So I could just simply say now +1. And what will this do? This will push my lower limit to 1 and my upper limit to 100. This integer function is going to convert whatever number is returned to an integer. It'll drop the floating point value. Okay, and it's possible that we can get any number between 0 and 0.99999. So anything that we get, we convert it to an integer and we add it to 1. So we'll get a number between 1 and 100. We're going to see a similar concept to this. And we could say N4, utilizing C programming. And remember the goal here is that by the end of this class, we want to be able to write a program. By the end of this class, we want to be able to write a program that would allow me to store a set of random numbers within a range inside of an array. It sounds harder than it is. It's really easy, actually. So I'm going to show you all here how to create a random number in C. Okay, so I'm going to create empty file, and I'm going to, we might include stdio.h, include stdlib.h, int main, and save this, and I'm going to name it random.c. Okay, right.
In the second line, std is supposed to put in std.
Oh, thank you. All right. I'm also going to have to include something called time.h. And the reason for that is that in C, we generate random numbers based upon the time that is currently now. So in computing, there's something called the Unix, UNIX equinox. And what this is that this is the amount of seconds since, of course, if you're using military time, midnight of the 1st of January, 1970 to now. And of course, this keeps on going. This number keeps on going, right? So this is the start of computing time. The Unix equinox is the start of computing time. And what we do is that we use this number as a seed into a function that was built in C, that once you put a number into it, you get a different number out of it. Right? It I really forget what you call it. They call it a seed for the random number, but I forgot what you call the process of doing it, so forgive me. But once you put a function, one number in to the seed, you always get the same random number out. But what if we take the amount of seconds that has passed since the Unix equinox to now and pass it into that function? What's going to happen? Every time we call for a random number, there's a difference in terms of how many seconds have passed between the Unix equinox and now and the last time you called it. So in theory, you get a new random number. Okay? Don't concern yourself too much about this, right? Just, this is one of those things that you kind of have to half accept. And I'm going to do some things here, and I'll explain it as I go along as best as I could. Okay? Sorry. All right. Right. So we have a variable called t, and it's of the data type time_t. So this variable holds the amount of seconds. Sorry, this variable allows us to access our computer's clock. And what we have now is that we have a function called srand, which is what I was telling you all about, and I'll show you all in two different ways. And then we have printf %sign b rand. So the function rand returns a random value, or returns a number, sorry, based on the number placed in srand. So if it is that I put 11 in srand, rand will always return a value based on the number 11. Okay? So every time I run this, I get the value 74. Look at this again. 74. 74, right? Because my number inside of srand has not changed. If I change srand to 12, I get a new number, 77. Okay, I change this to 6, I get a new number, 58. But the thing is, once the numbers are always linked. So how do I get a change in value to pass into here? I pull the value from the clock of the computer. Why? Because a clock always has seconds moving forward. Okay? So if it is that I want to have a value srand, I could say unsigned, and unsigned just simply means all the bits are assigned to the size of the number, right? Again, don't hit your head about it. These are concepts that we will talk about in the future, but what we put down here now will work as it is, right? We have time, and then we have ampersand t. What I'm doing here is unsigned is a type of integer. All I'm saying is that we are turning this value that we're getting from the time of the computer into an integer, and we are passing it into the srand function. Now, we have been using built-in functions. Printf is a function. Getchar is a function, right? And just like maths, you do the innermost brackets first. So what is this? This is a function that says get the time of the computer, and this part here says turn it into an integer and pass the time of the computer as an integer as the seed for this random number. So now every time we call this function, we should get a slightly different number. Okay? You notice the numbers are always going up. As I said, it's pseudo-random. But if it is that we work to put it within a range, let's say we wanted this number to fall within the values of 9 and 50. Okay, so if I want a random number between 9 and 50, a random number between 9 and 50, let me ask a question. If I have the number 222, and I wanted to get the mod of 222, and again any number 215, 193, 75. We want to see what number, any number in this range, how we could get it down to between 9 and 50. What can I do with these numbers to get a value between 9 and 50? First of all, go on. Let me hear you.
By 10.
Divided what?
Divide by 10, sir.
Divided by 10. But then we get 7.5 in this instance. That's not between 9 and 50.
Oh, true.
But I like where you're thinking with that.
So
Anybody else?
So you could put a condition
A condition saying what?
saying that basically to only take numbers between 9 and 50.
Okay, but so then we what if this instance is an instance where it, we can't really prompt a user or anything. So let's say these are readings that we want just like in the case of the clock, we have to take whatever the clock gives us and bring it into the range 9 to 50. You follow me?
So we could probably modify 50, sir.
We start getting into to what we're thinking about. Yeah. But what if this number, let's say we had a number 103 here. If we mod 103 by 50, we'll get 3. So what do we do there?
If you modded it by 5.
Huh?
Modded by 5.
Or modern 103 by 5 will still give you 3. Yeah?
Yes, sir.
I like how you guys are thinking. Okay, I'll give you the solution, but I just like for us to kind of think through.
Yes, sir.
What is the difference between 9 and 50? What is the difference between 9 and 50? Huh?
41, sir.
Right. So we can mod each one of these numbers by 41. Right? And what in this case, in all of these cases, we will get a number that falls between 0 to 40. Not so? Right? Because if you mod a number by a certain value, right? Or if we mod it, yeah. Let me go with 41 and then we'll make the adjustment because I done already write out all my 41s. But we have 0 to 40. Now, how could I get something that was 0 to 40, right, to now be every number that we get here, 222 mod 41? Could I get a number for that? If I mod it by 42, sorry. So let me mod it by 42. I'll get numbers between 0 and 41. Right? So 42. So anybody with a calculator there could give me 222 mod 42?
So I get 12.
Right. So the answer here was 12. 215 mod 42.
Five, sir.
It's 5. Yeah.
5. You're using a calculator or not? 193 mod 42.
I got 25.
Okay, 25.
Yeah, I got
75
25.
mod 42. I'm gonna put 87 mod 42 here. That's right. 75 mod 42 is what?
33.
33? 103 mod 42. Oh, we have 5 on this.
19.
19.
19 and 87 mod 42 is, that should be like 3 or something. So Yeah?
It's 3.
3. So look at the numbers that we have here. Right? 12, 5, 25, 30. Do they fall within the range?
No, I don't think so.
No. But what will happen? What is the lower limit of this here? What's the lower limit here? The
9.
lower limit is 9. So really and truly, once we do this operation, we could add 9 to this, and we could always be confirmed that the values will fall between 9 and 50. right? Because if I had the value 41 mod 42, that will give me a value of 41. And if I have the value of let's say 0 mod 42, that will give me the value of 0. But if I add 9 to any one of these values here, so let me just go ahead and add 9 and I'll write the answer. 12 plus 9 is what? 21. 5 plus 9 is 14. Right? That falls within the range. 25 plus 9, 34. 33 plus 9, 42. 19 plus 9 is 28. 3 plus 9 is 12. 41 plus 9 is 50. So we hit the higher limit here. And 0 plus 9 is 9. So for us to be able to get a number within the range, what we do is we divide whatever value that we get from this the random number according to the difference in the range plus 1, and then we add the lower value. Okay? So if I wanted to, and I'm erasing everything on screen here, right? If it is that I wanted to get random numbers between 1 and 100, or between 50 and 100, that happens, based upon this, I could say printf %d, and I call the rand function. I mod it by 51, and I add 50. And what I will get there is that I will get always a random number between 50 and 100. Okay, you'll notice that they kind of go up again, as I said, because it's because of the fact that it's counting up according to time. So it's pseudo-random, but it's random enough that we can get some values different every time. Okay? If it is that I wanted to get a random number between 25 and 40, I would mod it by 16, and I would add 25. And this will always allow me to get a random number between 25 and 40. Okay, so every time I run this number, it'll come up between 25 and 40. Okay, seems like it's stuck around the 30-something value, but you should be able to get like a 25, or could go down to 33 there, or 26. Okay, so folks, I have shown you all how to put values into an array utilizing the scanf. I've shown you all how to print values from array, and I've shown you all how to generate a random number. You all know what's coming now. Do you know what's coming now?
Break.
A break time, and then followed by an exercise. And the exercise would involve us having to populate an array of size 10 with 10 random numbers and printing out those random numbers to the user. Okay? So I will send you all on break. I will type up the question, and when we come back, we will spend some time. So you have 10 minutes break, so it's 2 or 3, we go into 2:13. You come back, and then we get till about 1:30 to do the exercise that I'm about to type up now. Okay?
Sir, before you go to break, could you show the the arrays C thing again?
Yeah.
Thank you. Hold on.
Oh, it switched back to random. Let's see. Right.
Yeah.
Okay. All right. So we'll consider it a break till 2:15. So take 10 minutes, you'll come back at 2:25. Sorry, 2:15 you'll come back at. And then we'll have from 2:15 to 2:30 to attempt the question that I'm about to type up on the screen. Okay? So, okay, so I'm just saying it for the recording. Write a C program that allows the user to enter two values, which indicates the bounds of random numbers that will populate an array of size 10. Display the contents of the array once it has been populated with the random number.